This is your review for motion and kinematics. Remember that at the beginning of the year we started out studying motion by having somebody walk at a constant velocity down the hallway, and we graphed their motion as a function of position over time. So a picture of that may look something like this, where we see somebody walking and we see where they're at 1 second, 2 second, 3 second, 4 second. We took that information and then we graphed it. So when we graphed it, it looked something like that, where we saw that the position was changing over time, and we would draw a best fit line, and then the slope of that line told us how fast the person was moving. So the fancy name for that slope is the velocity. So that's where we got the equation. Velocity is change in position over change in time. Remember that the unit for velocity would be meters per second. Remember, we could also write it like x equals vt plus x0, just writing it in y equals mx plus b form, where x subscript 0 stands for the initial position, or the starting point. So this graph represents something that's moving forward with some positive initial position. We could also graph the motion of something that's moving backwards. That would just be something that has a negative slope. That would look like that. Remember, if something is moving faster, it's going to have a steeper slope. So if I want to show something that's moving faster than the blue line that I drew, that might look something like that. And then finally, remember, something that's not moving is going to have a zero slope. So that line represents something that is staying at rest. So remember, anytime you see a flat line on a position time graph, that means the object's not moving. Sometimes we have multiple objects moving in a given situation. And when we have multiple objects moving, we refer to that as relative motion. Questions like, what is the velocity of one thing relative to something else that's moving? So for example, suppose you had two objects moving towards each other, one moving at 5 meters per second, the other moving at 10 meters per second. And you wanted to know what the relative velocity of the two was, what the velocity of one is relative to the other. Well, always draw a picture to help you understand the situation. In this case, since they're moving towards each other, I would add those velocities together to get the relative velocity. So that'd be like 15 meters per second. If instead we made the second object go in the opposite direction, like that, now we would find the relative velocity by subtracting the two. So instead of 5 plus 10, we would now do 5 minus 10, which would give you like 5 meters per second. And it would be negative, indicating that it's moving away. In a different example, we have somebody on top of something that's moving. So maybe this is like a train and there's a person walking on the top. In this situation, draw a picture. Notice that the relative motion causes him to look like he's moving slower. So if you were to ask to figure out the relative velocity of the person relative to the ground, in this situation you would subtract. Remember, a good trick to figure out if you should add or subtract is to ask yourself if the person or object was moving at the same speed (10 meters per second) as the other object, would it still be moving? So if you were to stand on top of a train and run backwards at the same speed the train was moving at, you wouldn't look like you were moving from the ground. Kind of like running on a treadmill. So anytime you have a relative motion situation, start out by drawing a picture Use your picture to decide if the relative motion is causing the objects to appear to be moving faster or slower. If they're moving slower, then you're going to subtract. If it appears that it's making them move faster, then you're going to add. The next thing we discussed is relative motion. Accelerated motion. Accelerated motion means that the velocity is changing over time. There's three ways that you could be having a changing velocity. Either speeding up, slowing down, or changing direction. Remember, that was part of our circular motion unit. An object that is speeding up might look something like this, where there's more and more space between the objects every second. When you graph the position of something over time, as it's speeding up, that means the slope would be increasing. So you'd start out with a small slope. Flat means it's 0, and then you end up with some big positive slope. So that shows you that something is speeding up. Something that's slowing down would look like just the opposite. Your pictures of your object at different time intervals will gradually get closer and closer together as the objects slow down. So when you graph the position versus time of an object like that, it would start out with some big slope, and then it would gradually flatten out to 0. So start out with some big positive velocity, gradually go to 0. Remember that when you have an accelerating object, the position versus time graph is going to be parabolic. Your velocity versus time graphs are always straight lines. So if you're asked to identify what the velocity versus time graph looks like, remember that the velocity is the slope. So this graph starts out with a positive slope. Remember, at the vertex of a parabola, the slope is 0, and then ends up with some negative slope, kind of like that. So this velocity versus time graph would go from a positive to 0 to negative, and would do something like that. A position time graph that looked like that would indicate something that's starting at a 0 velocity, it's flat, and then going to some big positive velocity. So that velocity time graph would look something like that. Remember that the acceleration is defined as the change in the velocity over the time. So if you have a velocity versus time graph, that means the acceleration is the slope. Change in velocity over change in time. So the velocity is the slope of a position graph. The acceleration is the slope of a velocity graph. Remember, we have three other kinematic equations that we can use to figure out the position or time that's going to take an object to move someplace, or the acceleration. X equals initial position plus initial velocity times t plus 1/2 at squared. That's the first one. Position equals initial position plus 1/2 parentheses velocity plus initial velocity times t. That's the second one. And then the third one, velocity squared equals initial velocity squared plus 2 times the acceleration times the change in x. Write that a little bit neater. Remember, when you're faced with a problem and you're not exactly sure what to do, always start out by writing down your givens. What do you have, and what are you looking for? Once you do that, find an equation that has all those things in it. Remember, you have your formula chart to help you out with that. Solve the equation for what you're looking for, and then substitute your numbers and do your algebra, or your arithmetic rather, to get your answer. Don't forget that the definition of the acceleration is something that you can use to solve problems too. Acceleration is delta v over delta t. You can rewrite that equation like v equals at plus initial velocity, and that makes it easier to solve in some situations. Be careful with the definition of velocity. Velocity is delta x over delta t, but only use that when you know the velocity is constant. If you have accelerated motion, if something is speeding up or slowing down, then you can't use that equation. That assumes that the velocity is constant. Once we learned kinematics, then we started looking at things that were free-falling, things that you either drop or that you toss up into the air. Remember that the acceleration due to gravity is a constant. It's always the same number, 9.8 meters per second squared. Most of the time, we round that off to 10 meters per second squared, just to make our math a little bit easier. So there's two possible situations we can encounter. One is when we drop something. Remember, when you drop something, the initial velocity is going to be 0. That's something that we have to remember. It's going to fall to the ground some distance, delta x. And remember, when things are falling downward, make the acceleration due to gravity positive 10 meters per second squared. The second situation we may encounter is something that is thrown up into the air. Remember, in this situation, you start out with some positive velocity going upward. It's going to go up and come down. Right before it hits the ground, the velocity is negative, whatever the initial velocity is. That's something to remember that's going to make this kind of situation easier to understand. Of course, our object is going to go to some positive maximum height. Remember, at the maximum height that your velocity is 0. When things are thrown up, remember to make your acceleration negative 10 meters per second squared. If something is moving forward and it's in free fall, then we call it a projectile. Remember, in projectile motion, the object is free falling in the vertical direction, up and down. We call that the y-axis. And it's moving forward at a constant velocity, so moving forward horizontally, we call that the x-axis. The equation we use in the y-axis is this one right here. Remember that for your problems, make the initial y position 0, and the initial velocity will also be 0, because usually we're just going to have things moving horizontally to begin with. So the equation is going to reduce to y equals 1/2 at squared in the case of a projectile. The equation that we use in the x direction is just our constant velocity motion equations. So you don't have to do much thinking when you see a projectile. You know that you're going to use the blue equation there to do the y-axis part, and the red equation there to do the x-axis part. Remember that the key to projectile motion is to find the time first. Remember to write out your givens and your unknowns, and whatever side you have the most information for, that's probably going to be what you're going to use to figure out the time. So for a projectile, a simple picture might look something like that. Remember that the horizontal velocity is always constant. So if I were to ask you to draw the velocity vectors on there, they would all be going forward like that. Call those all Vx. If I would ask you to draw the vertical velocity vectors, remember that they go up initially, and as it goes up it starts to slow down until we get to the maximum height when it's 0. Coming back down, they get bigger and bigger, again because we're being accelerated due to gravity. Remember that the position time graph, we need 2 of them, one for x, one for y. For x, it's just something moving forward at constant velocity, and the velocity graph is just a flat line. The y velocity would be a straight line sloping downward, and the position going up and down would be a parabola, kind of like that. Remember that at the top of a parabola, your velocity is 0.